Welcome to Section 5.3, Strings as Character Arrays. In this lesson, you will learn how C stores text. Let's get started. Welcome back. So far you have stored numbers in arrays. Integers, doubles, scores, temperatures, but programs deal with text all the time. Names, file names, messages. In this lesson, you will learn how C stores text. The surprising part is that C has no string type. It reuses the char array you already know. Let's see how. This is the plan for this video. First, you will learn what a C string really is. C has no string type. A string is just a char array that ends with a special null terminator. Next, you will see how to create strings. You will use string literals, declare a buffer to hold text, and let the compiler count the size for you. Then you will learn the difference between length and size. Length is where the text ends, and size is how big the buffer is. You will also process a string one character at a time. After that, we focus on reading input safely. You will see why plain scanf is risky, what a buffer overflow is, and how fgets reads a full line without that danger. Finally, you will change characters inside a string, and learn about the classic bug of forgetting the null terminator. You have stored numbers in arrays. Integers, doubles, scores, but what about text? A username, a file name, an error message. In many languages, a string is a built-in type with its own operators and automatic memory. C does not have that. Instead, C stores a string as an array of char values ending in a special marker. This design is simple and efficient. It is also dangerous, because one wrong index can corrupt memory. So what is a C string? It is a sequence of char values ending with the null terminator. That null terminator is written \0. There is no length field, no special object, no metadata, just characters followed by a 0 byte. A C string is a contiguous sequence of char values where the last character is the null terminator \0, which has a scii value 0. It marks where the string ends. Every standard string function in C relies on this convention. This is a string in memory. It is just a row of char cells indexed 0 through 6. Right now they are empty. Now the characters appear. Capital H, then E, L, L, O, and the new line. That is the text you can see. 6 characters stored one per cell. But the string does not stop there. The 7th cell holds the null terminator written \0. It is drawn with a hatched border to mark the end of the string. Every C string has one. So the total is 7 bytes. 6 characters plus one null terminator. The terminator is never printed. It is only a marker that says the string ends here. Let's zoom in on the null terminator. It is the character with a scii value 0, and it marks the end of a C string. Be careful. It is not the digit 0, and it is not the null pointer. \0 is the null terminator with value 0. Single quote 0 is the digit character 0 with value 48. That is a different thing. And plain 0 is the integer 0 with value 0. It has the same value as \0, but writing \0 makes your intent clear. This is a string terminator. You have been using string literals since your very first program. A string literal is a constant string written in double quotes, such as hello. The compiler stores it as a char array and adds the null terminator automatically. So hello has type char array of size 6, 5 letters plus the terminator. You never write the \0 yourself in a literal. The double quotes take care of it. This is a distinction that trips up many beginners. Single quote A is not the same as double quote A. Single quote A is a single character. Its type is int, and its value is the integer 65. Double quote A is a string literal. Its type is char array of size 2. Its value is the letter A followed by the null terminator. And the empty string, two double quotes with nothing between them, has 0 characters, but it still has the null terminator. It takes 1 byte. An empty string is a valid string with length 0. So single quote is a single character, the integer 65. Double quote is 2 bytes, 65 then 0. Completely different types. To store a string in a variable, you declare a char array large enough for the characters plus the null terminator. Here, greeting has 6 elements. 5 letters H, E, L, L, O plus the terminator. C lets you initialize a char array straight from a string literal, and it copies the characters and the terminator into the array. The %s format specifier tells printf to print a string, reading from index 0 until the null terminator. The output is one line, hello. Writing the size by hand is easy to get wrong, so let the compiler count. When you leave out the size and give a string literal, the compiler counts the characters, including the null terminator, and sets the array size for you. Here greeting becomes a char array of size 6. This is the safest and most common way to initialize a string variable, because you can never miscount. Sometimes you want extra room. Char name of size 50 equals Alice reserves 50 bytes. Alice only uses 6 of them. The other 44 bytes are set to 0. That is handy when a string might grow, like user input of unknown length. This is a buffer. It has room for 50 bytes. Let us watch what actually goes into it. First, the text, Alice, 5 characters ALICE in the first 5 cells. Right after Alice comes the null terminator. That is the 1 extra byte, so the text needs 6 bytes in total. 5 characters plus 1 for \0. A buffer must always be at least 1 byte larger than the text. The buffer has 50 bytes, so 44 are left over. This spare space is filled with zeros. It is free room in case you later store a longer string here. Be careful not to confuse two things. The length of a string is the number of characters before the null terminator. The size of the array is the total number of bytes allocated. They are different. Here the string Alice has length 5, but the array has size 50. The while loop counts the length by scanning forward until it hits the null terminator. That is exactly how the standard strlen function works. The length is not stored anywhere, so to find it, you must scan every character. The output shows length 5 and array size 50. Since a string is just a char array, you can process it with the same loop patterns you use for any array. The one difference is that instead of looping up to a known size, you loop until you hit the null terminator. This example converts to uppercase. For each lowercase letter, it subtracts the distance between lowercase and uppercase in a SCII to get the uppercase letter. Non-letter characters like the comma and the space pass through unchanged. Look at the loop condition. Message at I not equal to \0. That is the string version of I less than size. The output is hello, world, all in uppercase. You learn to read integers with scanf. Reading strings uses the %s format specifier. Notice the most important detail. There is no ampersand before name. With an integer, you write scanf %d &age to pass the variable's address. With an array, the name alone is already the address, so you drop the ampersand. And look at the width. %49s reads at most 49 characters, leaving 1 byte for the null terminator in the 50-byte buffer. Always give scanf a width with %s. One more thing. Scanf with %s stops at the first space. If the user types Alice Smith, it reads only Alice. This is why the width matters so much. Suppose you write scanf %s with no width into a 10-byte buffer and the user types Christopher. Christopher is 11 characters, plus the null terminator, so 12 bytes. The buffer is only 10. Scanf keeps writing past the end of the array. This is a buffer overflow. It overwrites whatever is stored after name in memory. In the worst case, an attacker can use it to run their own code. This is the single most exploited weakness in C programs. The fix is simple. Always give a width like %9s, which reads at most 9 characters and leaves room for the terminator. Or better, use fgets. Since scanf with %s stops at the first space, it cannot read a full name or a sentence. For that, use fgets. Fgets takes 3 arguments: the buffer, the size, and the input stream. Standard input, called stdin, means the keyboard. Fgets reads up to size -1 characters, or until a new line, whichever comes first. It always adds the null terminator. Fgets is safer than scanf because it respects the buffer size so it never overflows, and it reads spaces. But there is a catch. Fgets keeps the trailing newline character in the string. If the user types hello and presses enter, the line holds hello, then a new line, then the null terminator. You usually scan for that new line and replace it with a null terminator. Since a string variable is a char array, you can modify individual characters. Here, changing word at index 0 from C to B turns cat into bat. The null terminator stays in place. You only changed 1 character. The output is bad. But here is a common surprise. You cannot assign a whole new string with the equals sign. Writing word equals dog is an error. Arrays cannot be assigned after declaration. To copy a new string in, you copy it character by character, or use a library function like strcpy, which you will meet in the next section. Let's put it together with a function that counts vowels. Notice the parameter, char str with empty brackets. This is an array of unknown size. For strings, you do not pass the size separately because the null terminator marks the end. The loop visits every character and checks it against all 10 vowels, upper and lower case. When it finds one, it adds 1 to the count. The vowels in hello, world are E, O, and O3 total. So count vowels of hello, world returns 3. This is the mistake that follows directly from everything we have said. You write char word of size 5, filled with the 5 letters H, E, L, L, O, 1 character at a time. The array is full. There is no room for the null terminator. Now printf %s does not know when to stop. It reads past the end of the array, printing garbage characters until it happens to find a 0 byte somewhere in memory. The fix is to make the array 1 byte larger so it can hold the terminator, or much simpler, use a string literal. Char word equals hello in double quotes, allocates 6 bytes and adds the null terminator for you. When in doubt, use string literal initialization. Let's recap. A C string is a char array ending in the null terminator \0. There is no built-in string type. It is just an array with a convention. The buffer must be 1 byte larger than the text to hold the terminator. Remember the lookalikes. \0 value 0 is not the digit 0, value 48, and single quote A is not double quote A. Let the compiler size your arrays. Char name equals Alice makes a 6-byte array. Loop until str at I is not equal to the null terminator, and find the length by scanning. Read words with scanf and a width. Read full lines with fgets, and never overflow the buffer. A missing null terminator makes every string function read past the end. Next, writing your own length copy and compare loops each time is tedious. In section 5.4, String Library Functions, you will learn strlen, strcpy, strcmp, strcat, and their safe variants.